Hi everyone. First, let me say happy Super Bowl Sunday. Hope everybody is going off to a party or hanging out with friends and having a good time this Sunday. Also wanted to let you know that I thought that the last discussion was great. The one about the internal validity, whether or not it's BS or is it something that we should kind of hold as valid when it comes to Fitbit or other companies. So that was great. Everybody got into that discussion, and that was really good. This week, I'm going to put up another discussion that's going to be part of the Google Hangout that we'll have in a few days. But I will not put up an assignment, and I have been getting your assignments, so I do appreciate that as well. It seems like you guys are putting forth the effort, so it's great. It really makes my job a lot easier. Today's presentation is going to be on research traditions and really kind of going through some different definitions and theories related to research, and not necessarily the specifics of an article or the specifics of the procedure of research, but more kind of the theory around it. So let's get started. We're going to start with some terminology and then go into kind of what we think about in terms of knowledge. What is knowledge? But let's start with some terms. The first is ontology, and that is a study of the philosophy of knowledge. And there's epistemology, which is the philosophical study of how knowledge is actually acquired. And these terms relate to kind of a broad knowledge of a topic, and if you do have a broad knowledge of a topic, remember what we talked about last week, you can then very efficiently narrow down that topic to a very kind of clear focus. And that we saw that kind of in the article that I put out last week as the assignment, the article on the knowledge of parents related to concussion. At the end of the introduction, they basically say it's very important for parents to have that kind of knowledge of concussion, and that's where there's a gap in literature. So in a sense, what we're saying here is that these theories are they surround how it is that we actually do research. So again, epistemology, broad knowledge of the terms that are related to the topic. You can determine the type of study design based on this, and it also can focus on personal preference. So again, kind of making things a little bit easier for you trying to study topics and concepts that you are familiar with can make it a little bit easier. So let's move on to the nature of knowledge. There are a few different things I wanted to mention. The first is positivism, and this is scientific knowledge that is the only true and valid form. So this kind of gets to when we talked about prospective and retrospective kind of studies, this is objective measurement. This is really related in a sense to quantitative information, although it still could be qualitative. It doesn't just have to be numbers, but it's at least measurable. So when you do a study or you read a study that is objective, meaning it's looked at from the outside, it's measurable, so you have data that has been measured by some kind of instrument, whether it be a survey or it be some other type of piece of equipment or machine. You have statistical analysis, which shows the difference between two groups, and then you have causal relationships. This is considered the theory of positivism, true and valid form of scientific knowledge. Now, what do you get with positivism? Well, you get control, number one, because you set up the study design, and based on that design, you can control your groups, right? So you give one group an intervention, you don't give the other group an intervention, and therefore they become the control group against which you're measuring your data. You get replication, and replication is also known as reliability, meaning that you're getting the same values and the same data time and time again when you do the measurement. And also, you get hypothesis testing. So you you ask the question in the beginning, right? You set a hypothesis, which is a prediction, and then you can test that hypothesis through this type of this kind of research, positivism. Again, objective, measurable, involves statistical analysis, and provides causal relationships. So those are some pretty good pros to positivism. Let's look at some weaknesses as well. Or we'll look at the strengths and the weaknesses. So as far as strengths are concerned, the data is collected quickly, relatively, meaning, if you're doing a 10 to 12 week intervention, that's pretty quick. Even if you're doing a 6-month intervention, that's pretty fast. It's a lot faster than a 20-year longitudinal study where you're looking over, you're looking at a disease state over a very long period of time. Data collection usually takes place at one time. So per subject, you're probably collecting data at one point in time. Now, listen, there are other studies that require 2 to 3 visits to a lab to collect the data, but for the most part, it's not going to be like you're collecting data at 6 months and then you collect data again at 12 months and then again you collect data at 2 years. It's usually we collected data on Monday and then 48 hours later we collected another set of data and then 48 hours we collected another set of data. Okay, so it's within a week. So it's kind of at one time. And again, that one time is somewhat flexible. It could be a day, could be a week, but it's usually not that much longer. Time schedules can be planned. So you can say, my subjects are showing up between the hours of 9 and 11 o'clock in the morning. And the reason is we're focused on circadian rhythm and sleep rhythms. Or we want to measure, the effect of we call it a postprandial state, which means that, fasting state. So we're going to be doing our study 12 hours after their last meal. Last meal is allowed at 7 o'clock, so our study will be done at 7 o'clock in the morning till 9 o'clock in the morning. But again, you get what I'm saying. You can set the time. Very, very controlled environment. And a lot of it is sports related. And it's very interesting, and I want to kind of point this out, is that, a lot of the research that we read, especially in this discipline, exercise science, exercise physiology, is very much sports related or human performance related. And if you look at a lot of the research is often not done in free living situations. It's done in labs. So there's some kind, we need to kind of read that with caution. Maybe be cautiously optimistic, but we still need to read it with caution and say, if this is such a controlled environment, and okay, I saw these kinds of results in this environment, how's that going to apply to actual, actual game time or actual play on the field or whatever, but in a free living situation as opposed to a kind of a limited environment in the lab. So strengths are many, and weaknesses does not take all into account, meaning you can't study everything at one time, especially if the data is collected quickly. You can't take all into account. So again, we talked about a little the fishing expedition idea. You can't look at 20 variables. So you're going to look at 3 variables and then maybe do another study to look at other variables that you didn't get a chance to look at the first time. It obviates the emotion and perception, okay? The reason being is this is not a subjective way. It's not a subjective theory of research. It is an objective theory of research where you're on the outside looking in. So there's no subjectivity. There's no emotion. There's no feelings. There's none of that. And because that really will lead to bias in the study, especially if the researcher is the one that is having those emotions. And it focuses only on the tangible. Only the things that you can do, only the things that are feasible are the things that you can focus on. So positivism is often the theory we use when we do studies in our labs, like at LIU or any other university. It's that kind of theory that we're applying to our research. Post-positivism is a little different. One cannot gain a true understanding of the phenomena through only objective measured means. Okay, so if we're looking at a phenomena, whether that be related to sport or it's related to basic science or molecular science or whatever, there are those who feel that through objective means we cannot get a full picture. We need to look at other other things rather than the objective means. And maybe that means we need to look at something that is more subjective. So here's a for instance. Take this example, okay? You're doing a study that looks at the effect of a particular supplement on distance in biking. Okay, so you're basically going to have individuals take this supplement. One group's going to take the supplement. One group is going to take Kool-Aid or some other kind of powdery drink that looks like the supplement, and the other group is not going to take anything. And you basically have them doing a bike test. And you're going to measure the distance they travel on the bike, and let's say it's a stationary bike, and they could go for hours, 2 hours, 3 hours, whatever, based on the supplement, or based on the effect of the supplement. So now you're getting data on distance, and you're getting data on revolutions per minute, and you're getting data on heart rate, and you're getting data on blood pressure while you're getting all this objective, measurable information. What you're not getting is how tired they actually feel, how much pain they're in, if possible, and what their general overall feeling is. So there's no subjective information there when you're collecting just the objective stuff. So if you're just collecting heart rate and blood pressure and distance and revolutions per minute, well, then you're not really worried about the subjective. However, the people who believe in post-positivistic theories of research feel that there's more, that objective data is not the only thing we need. We need to find out what the subject's feeling, what the emotions are, because that plays into the psychology. Remember, a lot of the stuff that we see on the shelves of different nutrition stores, a lot of this stuff is about placebo effect. It's about the effect that you feel like not the effect, but it's about how you feel when you take it. So is a branched chain amino acid supplement actually doing something for someone during the workout, or is it the fact that they're taking a branched chain amino acid supplement that makes them feel better during the workout? Is the NO-Explode supplement actually physiologically changing the way that nitric oxide behaves in the vessels, causing greater oxygenation to muscle, or is it the fact that somebody took the NO-Explode and now feels that they can bench 350 pounds? So again, it really talks about what is the emotion, what is the feeling, what is the subjectivity. Post-positivism kind of gets at that. Theories can only be disproved. They don't feel in post-positivistic theories of research, they don't feel that theories can be proved but only disproved. So you can only refute the theory, you can't necessarily validate a theory. And it uses multiple methods to get at an answer. So again, we talked about methods and we talked about the importance of methods in a research study. In post-positivistic views, you use multiple methods to get at an answer, not just one method. That, I think, is a little bit, in some cases, that it may be not as feasible as using one solid method to get at an answer. Listen, most of the research that I've done in the past, I've used one solid method to get at an answer. If the answer wasn't in the direction that I felt it should be, then hey, whatever, that's what the data told me. But I didn't use necessarily multiple methods to get at an answer. I find that that's a little bit more manipulative. But again, that's a post-positivistic view. So if we move on, interpretivism is that concepts are too complex to only be measured in number. Again, they need to be interpreted, and this speaks to just what I was talking about, which is subjective measures of data, that the numbers don't tell everything. And let me give you a very, very interesting example. Many years ago, I was working at LIU, and I was doing a lot of work on autonomic function. I may have mentioned that before. I don't mean to sound like broken record, but I was doing work on autonomic function, and at the time I was working a lot with polar heart rate monitors, and the individual who was, I never even knew they had this division, but an individual who was the director of their special operations contacted me, and long story short, we did a study together. And our study was very interesting. We looked at the they weren't detecting, they were detonating explosives, believe it or not, and the effect on heart rate and the autonomic nervous system. So we had went down to Virginia Beach, and we had people who actually, they had mock bombs in many, many different ways. Like they had a bomb in a suitcase, and they had one scenario was there was a bomb hooked up to this very complex thing that was hooked up to this person's neck, that if they moved, the bomb would go off. And we had to watch these guys detonate the bombs, or defuse them, really, and see what happened to their heart rate and their autonomic function. How, had their blood pressure changed, their heart changed, the cycles of heart rate change, and all of that. The reason I'm bringing this up is because numbers were great, but they didn't tell the whole story, because we had great subjective information from these people who were defusing the bombs, and what they felt like, and how pressurized it was, because the numbers did not tell the story at all. Now, they told us a little bit about, how the autonomic nervous system function changed when they were going through these processes, but not anywhere near what that, that subjective information was. Interpretivism is also a theory that seeks understanding, but not only truth. So in other words, it's more linked to or aligned with explanatory research. So it's not about just like, all right, this is valid, great, okay, this device is valid, that's great, it measures what it says it measures, good, let's move on. It's more about, how does it do it? Why does it do it? It's about mechanism, and that's interpretivism. Again, you're interpreting the data. And it brings into play the perception of the subjects and participants. So again, speaking to exactly what my example was before, finding out how these Navy, they were Navy officers, how these Navy officers felt when they were defusing the bombs, was a real huge benefit to the data, to the numbers data that we had already collected. So now we've kind of talked about, in a way, both quantitative and qualitative types of data through positivism, post-positivism, and interpretivism. So let's take a look at what quantitative and qualitative really are. And so quantitative is kind of reduced to numbers. It's numerical measurement and analysis. Variables are directly measurable. Again, heart rate, blood pressure, respiration rate, force, distance, directly measurable. It's a contrived setting. So in other words, when you're looking at quantitative data, it's very difficult to do it in an uncontrolled setting. Now you could, that means it could be done in a free living environment, but there needs to be some controls over that. And let me kind of give you an explanation of what I just said. So way back when we used to do studies on human performance, we would study something called VO2 max, or volume of oxygen maximum. It was the amount of oxygen an individual could consume from the atmosphere and therefore deliver to working muscle, right? And we used to do it, and the way we used to do it, we had a big machine and a huge mask on the face, and measuring oxygen uptake and carbon dioxide output and all of this, and it had to be done in a controlled setting because you couldn't do it outside, the equipment was too big. Fast forward a few years, and they created devices that were a lot smaller, that could be kind of a backpack size device, with the mask and everything else, but now you could do things in a free living environment. However, it's still a contrived setting. People do not live with these backpacks on their back walking around with masks on their face. At least in Arizona they don't. I'm not sure if New York has maybe changed since I left. But what I'm getting at is that it's still contrived, it's still controlled, and the only way to get true quantitative data that means anything is to have that kind of environment where you're doing your testing. The other thing is that when you look at quantitative data, you can't say that there is you're not likely to say there's just a casual relationship here. You're more likely to say there's a causal relationship, but you have to be very, very careful when you do this, because here's the example on the slide, okay? The effect of ingestion of carbohydrate on power in hot environments. Okay, great. So I have someone take a carbohydrate supplement, and then I have them get on a bike, and I have a power meter on the bike, and I measure the power in regular environment, a cold environment, and a hot environment. And I have all three of my groups kind of cross over. So every one of my subjects does it in each environment. So I see how each subject responds to each environment with this carbohydrate supplement. But the question is that a causal relationship? In other words, is it just kind of a alignment, maybe an association between carbohydrates and the power that you can generate in a hot environment? Or can I say it's causal? Can I say the reason why an individual generates more power in a hot environment on a bike is because of this carbohydrate supplement? That's a very, very bold thing to say. So you need to have really good statistics and solid data to be able to say that. However, in quantitative type reasoning, that's what you're after. You're after the idea that you can say there is a cause, there is a reason why I found this or I have this finding, and it's because of my intervention, or it's because of my supplement, it's because of what I did, whatever. It's a causal environment. It causes the result. So kind of be careful when you say that. Again, that's kind of a statement of absolution. It's a statement of being absolute. Definitely, this carbohydrate absolutely affected the power of the cyclist in this hot environment. You have to be real careful when you say something like that. But that is what quantitative data is after. Qualitative data, on the other hand, measures meanings and qualities that are not measured by number. So meanings and qualities, so again, emotion, feelings, describes and promotes the understanding of concepts. So, for instance, there is something known as the Rating of Perceived Exertion Scale. Borg created it in the 1980s, and it's still used. And originally, the scale was a scale from 6 to 20, where when you measured heart rate and multiplied any of the numbers on the scale by 10, you would get the individual's heart rate. So if the individual was reporting I'm a 6 out of 20, meaning this is how hard I'm working, I'm a 6 out of 20, heart rate was usually 60. If I'm a 15 out of 20, my heart rate's 150, and if I'm a 20 out of 20, my heart rate's 200, and that was kind of the maximum. In the last few years, probably the last 10 years or so, maybe even 15, the scale has changed a little bit from a 0 to 10 scale. Similar kind of, similar information, but what you're saying now is that the subject easily understands a 0 to 10 scale rather than a 6 to 20 scale. So, what is the concept of RPE? The concept of RPE is understanding the individual's exertion relative to the activity that they are doing at that moment in time, right? So the RPE, the emotion, the pain, whatever it is that is causing that RPE to increase, gives us more insight into the actual concept of what it is that we're doing, whether it be supplementation, whether it be, it doesn't matter what it is. Muscle biopsy, bike testing, treadmill testing, whatever it is, it gives us more insight into that concept. You can use smaller samples or cases. Well, with qualitative information, you do use smaller samples of cases, but let me kind of state this clearly, is that when you're looking at quantitative information, if you're using equipment or an instrument, it takes a long time. It has to be feasible. You have to have the resources. And to be honest with you, to get people to go through a 10 to 12 week training study, whether it be aerobic or strength training, flexibility, it doesn't matter. You get a lot of dropout. So I don't necessarily think qualitative always uses smaller samples or cases. But quantitative tends to be small. If you look at most of the studies out there, you're probably looking at sample sizes under 50 for the most part. Qualitative information, if it's done on a survey, there are, cancer surveys that collect qualitative information of thousands of people. Censuses, thousands of people. So I don't necessarily think it's always smaller. But I do think, though, qualitative information lends itself to case studies, as opposed to quantitative information, which is not as robust if it's a case study, meaning just one case at a time. The location is often natural, meaning again, you're surveying a population, they're in their free environment, or you're doing something, there's an intervention in a free environment which is not controlled like a laboratory, and you can get good qualitative information there. And the interpretation is key too. Understanding what the information means is key. So along with studying the people who defuse bombs, I also studied SWAT teams, which was really, really interesting. There was a kind of a mock terrorist scenario that was set up in a high school, and you watch them go down the hallway with their guns drawn, and how they split up, in their teams to kind of get the terrorists, and it was amazing. But the interpretation of that qualitative data was so important. And we had our SWAT teams take state and trait anxiety inventories, meaning state anxiety is how you feel at that moment, trait anxiety is how you feel in general. The interpretation is key, and that's a little bit past my pay grade in terms of the psychology part of it. So we had psychologists look at that information. But if you don't interpret it correctly, then the data you're getting is kind of faulty. The example here, narcissistic qualities in college athletes, was done by somebody in our psychology department at LIU that I actually helped with. So let's choose a direction. What's the direction you want to go in? Base your decision on your objectives and your research question, and try not to shy away just because one path seems more difficult. If you feel that quantitative data is what you want to collect, and it's going to be a little bit more difficult to get, but the quantitative data is just not feasible, then I say go in the direction of the qualitative data. Same thing, on the other hand. So it really depends on what's going to work out for you. You can mix the quantitative and qualitative too. This may be seen as a negative or a positive. So if you mix the two, you might see it as a negative, as it's either too much data or it's going to be too hard to collect all that data. Or you might see it as a positive, where it makes for a more robust study. It really depends on what population you're looking at and how feasible it is. Or one may complement the other, right? So in the study we did on the guys defusing the bombs, we had quantitative data in autonomic function and heart rate, and we had qualitative data in terms of their psychology. So it did help. But both approaches may work toward the same end. So you may end up, not necessarily with the same result, but you may end up with a very robust, very kind of high quality study if you use both of them, and they may work toward the same end. So an example, the effect of fitness for people with Parkinson's on leisure time physical activity and community socialization. So the effect of fitness for people with Parkinson's. So yeah, of course we can measure that quantitatively. We have numbers for that. But also, don't we want to see how their community socialization is affected by fitness? That's going to be tough to do. What are you going to do? Count how many community meetings they went to? That's not really going to tell you much. But if you get into their head and find out how their socialization has changed due to the fact that they have become fit, then that could be, very robust and could have a lot of power in terms of a study. We're going to look at two different kinds of research. Deductive research, more along the lines of the positivist movement, and quantitative data. This is, again, the perspective, the retrospective, they all kind of fit together. Development of an idea or hypothesis is definitely a component of this and can be tested through a collection of data. So this is the kind of studies that we read. It's the kind of studies that we're used to. The process is... there's a statement that's used to underpin the research, right? So to kind of bolster or support the research, there needs to be a statement. Usually that's kind of a hypothesis. That's what we're after. If it's true, then there's a relationship between the variables, and if it's not true, there's not a relationship between the variables. We do a collection of data to determine this, and then we report our results, or at least look at our results to confirm, modify, or refute the theory, right? Or refute the hypothesis. This is deductive research, using deduction to try to figure out whether or not the thing that you're doing in your research is actually affecting your results, or, is your prediction correct? So we try to deduct that. Inductive research is more aligned with the interpretation and more aligned with qualitative information. So the process is we collect the data, we analyze the data, then we develop a theory or hypothesis, then we test the theory. So We collect the data. Okay, so what are we doing? So we're not necessarily doing a 10 to 12 week training study here. What we might be doing is looking at the consumption of cigarettes among individuals ages 15 through 25 and then looking at rates of lung cancer. So we collect that data, we then analyze that data and see that there's a 65% incidence of lung cancer in people who've been smoking for more than 8 years. So from the age of 15 to 23. We then develop a theory or hypothesis and say that cigarette use between the ages of 15 to 25 cause a 65% incidence rate in lung cancer, and then we test the theory, right? So then we test it. Then we go out and we look, number one, we find populations. We look at more rates of lung cancer. We look at those rates of lung cancer related to age groups. We look at what's in a cigarette. Like it's getting into a little bit more of the chemistry of the cigarette, looking at how it affects the lungs. And we try to bolster or support the theory based on the data that we collected. So that's inductive research. Again, a little bit more related to qualitative characteristics and also based on strong interpretation. So how do we choose? You always come back to your question, whatever your question is. I think in the case of our question the last time, it was, I don't remember the question from last time. So let's pull another question. Let's talk about, let's say concussion rate in female soccer players ages 18 to 25. So what do we want to find out? We want to find out if there is a higher concussion rate. How about this? Concussion rate in female soccer players ages 13 to 18. Is that rate higher than those individuals who are in college and in the pros? That's my question. Am I exploring an area of content where this is a substantial amount of information? I wouldn't say a substantial amount, but I would say there's more now than there was before, for sure. There is data out there to show that 1,000 headers in soccer can lead to, concussive types of symptoms. Are we exploring new paths and blazing new trails? Well, concussion now has become a hot topic. It's a buzzword. And I think not only in football, but I think in soccer, it's being looked at much more closely. So I don't know if it's a new path and I'm a pioneer blazing new trails, but I think definitely that question, if it had not been answered already, definitely could add to the literature that's out there. Do I have the resources? Well, if I'm at LIU, yes, I have the resources. I have a soccer team. I have a soccer coach that's willing to participate. I have an entire season to look at this, the soccer team. That's going to be a team that's 18. And I also have connections to high schools. And high school soccer programs through the coach at LIU. So yes, I have 100 soccer players whom I can actually take a look at and do pre-testing, preseason testing for concussion, and then look at postseason testing, or, there's many, many different instruments I can use. So yes, is there a risk to doing it? Well, there's always a risk to doing any kind of study. The risk would be losing subjects. The risk would be not collecting the data. But at this point, no, I would say the risk is kind of minimal. And also, I'm not asking the players to risk themselves. This is what they do. They're playing soccer. So I'm not asking them to do anything that's outside of their normal play. Lastly, how do I feel? Be true to myself. Do I only want numbers? Not necessarily, no. When it comes to concussion and questions that relate to head injury, I also want to get information on feelings and emotion. Is it just important to record feelings, emotion, and perception? No. I also want numbers. So I'm going to use things like the impact test, and I'm going to use other types of instruments maybe to get some preseason information or data. What are my resources? Just kind of went over that, right? I have a soccer team, I have a coach, I have high schools willing to participate. And are you trying to explain why or just describe and observe? Well, interestingly enough, at this point I'm describing and observing. However, maybe later, yes, I would like to describe why or understand the mechanism behind it, right? It's probably a similar mechanism to subconcussive blows that a lot of football players experience that kind of lead to CTE, chronic traumatic encephalopathy, but not right now. I'm not interested in the why. I'm only interested in the describing and the observation. So one more thing. Let's talk about the hypothesis. There are two different kinds of hypotheses that we can set up, and again, this is the prediction we make based on what our data looks like. So the first is a null hypothesis, where we're saying there is no relationship between the variables. So if I support the null hypothesis, that means that my results are not favorable, right? I'm showing no relationship between the variables. And usually that's what I'm looking for. I'm looking for a relationship between the variables. If I reject the null hypothesis, that means I am actually saying there is a relationship between the variables. There is a relationship between heart rate and diffusing a bomb. There is a relationship between cigarette smoking between the ages of 18 to 25 and 65% incidence in lung cancer, or just lung cancer. There is a... I'm, again, rejecting the null hypothesis. There is a relationship between the use of video games and improving function and coordination in people with Parkinson's, whatever it is. So in this case, the empirical testing may yield a null hypothesis rejection that moves in the predicted direction. Okay? Again, I am predicting there's a relationship between the variables, therefore I am rejecting the null hypothesis. Think of the null hypothesis as zero. When you reject zero, you have something. So again, I know it's a little bit abstract and difficult to get around, but if you've been through research, you kind of know what I'm talking about. And if this is the case, then one can say there's a relationship between the variables. If I reject the null hypothesis, there is a relationship. If I support the null hypothesis, zero, there is no relationship. However, even if I reject the null hypothesis and say there's a relationship, I cannot comment on the magnitude or effect size of that relationship. Meaning, I can't say how powerful that relationship is. I can only say there's a relationship. So yes, smoking between the ages of 18 to 25 can result in lung cancer. There's a relationship. Using video games in people with Parkinson's improves coordination and balance. There is a relationship. How do I determine how powerful that relationship is? That's where I go to my statistics. My statistics tell me how powerful that relationship is. When I look at a directional hypothesis, I predict the direction of the result. So with quantitative data, I say not only is the direction going to be a positive relationship, or not only is the direction going to be a negative relationship, but I say something about how powerful that relationship is going to be. And usually I predict that basis on existing knowledge. So there's been studies done. There's a study that's been done 5 years ago on the effect of the use of, let's say, video games in the traditional sense, using thumbs, on coordination and balance in Parkinson's, but I have a new video game. I have a Dance Dance Revolution video game where you use your feet and you have to follow arrows on a screen. And I think, hey, wait a second, if that had such an effect 10 years ago, I predict this is going to have this kind of effect. A positive effect, very powerful. So again, you have the null hypothesis, which is either going to be supported or rejected. Either there's going to be no relationship between the variables or there will be a relationship between the variables. And then you also have a directional hypothesis, which is a little bit more, you're going out on a limb there. Because if you have a directional hypothesis, you're really saying this is the direction it's going in and this is where I'm laying my bet down. Because based on existing knowledge and based on previous literature or previous studies in this topic area, this is what was found. So that's the end of our show. A lot of stuff, about 39 minutes, and I'll be off in about a minute and a half, but I did want to remind you we are going to have a Google Hangout this week. I will put up an update tomorrow. I have everybody's Gmail, I believe. I will be inviting all of you. and I think the time is Thursday. It's this Thursday. I believe it was at 9, maybe 9 p.m., 7 p.m. my time, but don't worry about it. I will send the times and everything, and I'll send you an update. Again, I want to thank you for listening. Have a wonderful Sunday. Enjoy the Super Bowl, and I will be in touch this week. Okay, take care.